Hello, everyone, and welcome back to another episode of Grade 9 Math Online. My name is Nikisha Bailey, and I am your teacher for today's lesson. Today, our focus will be on performing enlargements with the center at the origin with scale factor k, where k is a natural number. Throughout this lesson, you will hear the following terms being used: enlargement, origin, scale factor, natural number, transformation, image, object, similar, congruent, center of enlargement, and orientation. Some of these terms you are already familiar with, while for some, you may need some clarification or explanation. These will be done at different points during the lesson. Let's get started with an icebreaker. You plotted the following shape on the Cartesian plane. Use a diagram to answer the following questions. What are the coordinates of A, B, C, and D respectively? State the name of the polygon. Find the area of the shape in unit squares. Were you able to answer all the questions? Let's look at the answers and see how well you did. Before I reveal the answers for the first question, how do you identify the coordinates of points on a Cartesian plane? Very good. Just like the alphabet, where x comes before y, we always record the x coordinate first. The location of the point is at the intersection of the x and y coordinates. So, A is located at -4, 2. B is located at 2, 2. While the coordinates of C and D are -4, -2, and 2, -2, respectively. Now, what name did you give to this shape? If you said the shape is a rectangle, you are correct. But what if someone said the shape is a quadrilateral or a parallelogram? Would that person be wrong? No. All these terms can be used to describe the shape. The difference is that some terms are used when more details are known. Finally, we can find the area of the shape by counting the squares. The area is therefore 24 square units. Since our topic for today is enlargements, did you know that there are many examples of enlargements that even you use on a daily basis? Yes, there are. Can you think of any? Let's look at a few examples. We encounter some form of enlargements when we use models of cars, trains, and planes, overhead projectors, zoom lenses on cameras, movie projectors, magnifying glasses, telescope, microscope, or binoculars, the television, photocopier and scanners, just to name a few. Now let's explore the mathematical aspects of enlargements. Take a look at the diagram and state your observations. Did you notice that both triangles are right-angled triangles? Yes, they are. What else did you notice? You should also have observed that the ratio of PQ to QR on both triangles are the same. This means that the triangles are similar. Let's take a look at another diagram. Here, we're asked to focus on the origin 0, 0, where X marks the spot. What are your observations? If you said any of the following, you are on the right path. Both triangles are similar. Corresponding lengths are proportional. The distance from the origin to each point on the image is a multiple of the distance from the origin to each point on the object. Now let's take a look at the same diagram from a different perspective. What else do you notice? Excellent job. The angle in both triangles are equal or congruent, and the triangles have the same orientation as with the ones we have looked at before. Here's another example for you to look at. You are told that 1 centimeter represents 1 unit. From the diagram, we can see that AB is 1 unit long, while AC is 2 units long. Also, DE is 2 units long, while DF is 4 units long. AB and DE are corresponding sides, while AC and DF are corresponding sides. If we look at the lengths of these corresponding sides, we can see that the lengths of the sides in the larger triangle are actually 2 times the length of their corresponding sides from the smaller triangle. Therefore, the size of triangle ABC increased by 2 to form triangle DEF. Good detective work, everyone. Now, let's list all that we discovered in our investigations. An enlargement is a transformation of an object that has the same shape but increases in size of the object. A scale factor is how many times larger than the object the image is. The angles of the original object and the image are the same, but the lengths of the sides are increased. An enlargement is an example of similar shapes. When changing the size of an object by an enlargement, we do so from a point called its center of enlargement. And for any enlargement, The distance from the center of the enlargement to a point on the image is equal to the distance from the center of enlargement to a point on the object multiplied by the scale factor. Let's have some practice using all the points that we just mentioned. Enlarge triangle PQR from the origin using a scale factor of 3. Label the object appropriately. From the origin to R, we have extended across one square. Therefore, if we're using a scale factor of 3, from the origin to R prime must extend across 3 squares. This takes R prime to 3, 3. R and Q share the same y coordinate in the object, and so this must remain in the image. So already we know that the y coordinate of Q prime is 3. The x-coordinate can be found by multiplying the x-coordinate of Q in the object by the scale factor 3. This gives 9. Therefore, the coordinates of Q prime are 9, 3. Finally, the coordinates of P prime can be found by keeping the x-coordinate of R prime and multiplying the y-coordinate of P by 3. This gives 3, 9. The vertices of the image would be P prime, 3, 9, Q prime, 9, 3, and R prime, 3, 3. Here's another one for you to try. By taking similar approaches as with the previous question, the vertices of the image would be J prime, 2, 2, K prime, 6, 2, L prime, 6, 8, and M prime, 2, 8. Now that you've found all the clues and have gotten some practice, it's time to solve this mystery. Michael presented this diagram as work he did while learning about enlargements. Describe fully the transformation that maps triangle B to triangle A. Justify your answer. I will now pause to give you some time to answer this final question. Let's see how well you were able to solve the problem. From the diagram, we know that the ratio of the corresponding lengths of B to A are all 1 to 3. This transformation is an enlargement from the origin with a scale factor of 3. Congratulations, everyone! You did it! You successfully solved the mystery. This is where we end our lesson for today. I hope you're comfortable performing such enlargements. Thanks for watching and see you next time.